All right, so this chapter is chapter 2 in section 3, and we're going to work with arithmetic operations on matrices. So the first thing we want to talk about is the size of a matrix. We identify it by its rows and columns. So when we talk about size, we say rows by columns. So for instance, if I had this matrix, 1, 2, 3, 4, 5, 6, I would say that it has 3 rows, so we'll say 3 by, and it has 2 columns, so 2. This would be a 3 by 2 matrix. Now, some definitions I'm not going to write down specifically. I'm just going to talk to you about them and just visually show you them. One is a row matrix, and what a row matrix is that it has only one row. So something like this, say 1, 2, 3, 4. This would be a row matrix. Then we also have a column matrix, which is just one single column. So this would be a column matrix. Next, we have what we call a square matrix. A square matrix is where your number of rows is the same as your number of columns. So we say like a 2 by 2, so it has 2 rows, 2 columns. 3 by 3, 3 rows, 3 columns. 4 by 4, and we keep going. Now the next thing is every single value inside a matrix is called an entry. So all of these values in here, they're called entries inside the matrix. So if I said, if I gave you something and it said this is saying that it wants you to find the entry of, and it has a subscript of 12, but what does 12 mean? Let's get into that. So the 1 and the 2 have different meanings. The 1 is the row, and the 2 is the column. So if I gave you, let's say this matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I said that I want A sub 12, so I know that it's row 1 and second column. So here's the first row, and then here's the second column. Then my value that I'm looking for is this one right here. So if I had to rewrite it, I would say that A sub 12 is 4. My entry in my first row and second column is 4. I know this is not anything to do with arithmetic operations. This is really us just being able to identify these things. So let's go ahead and start our arithmetic operations, and we're going to start by addition and subtraction. So in order to add and subtract matrices, the one thing that has to be true is that they have to have the equal size. So matrices have to have equal size when you're adding or subtracting. Meaning a 2 by 3 plus a 2 by 3, I don't know, a 3 by 1 minus a 3 by 1. They have to be the same exact size. So let's go ahead and start here, our first example. And we're going to say 1, 2, 3, 4, 5, 6 plus 7, 8, 9, 10, 11, and 12. So what we're doing here is we're taking these matrices and we are just adding them together. And we're going to add the exact same spot. So what we're doing is we are going to add 1 plus 7. I'll write it out. So it's 1 plus 7. That's going to give us our first entry. Next one will be 4 and 10. 4 plus 10. And we just keep this up. Next one, let's say 2 and 8. So we say 2 plus 8. And we just keep going from there. So I'm going to ask you to stop this and try it on your own and simplify and see if you get the correct matrix based on what we're doing here. So go ahead and pause now. When you come back, it'll have all the answers. How'd you do? All right? So you can see that we're just adding those same entries from different matrices. All right, moving on. Now let's look at, that's adding, subtracting. Let's look at multiplying. So multiplication has a different rule. So addition and subtraction, you have to have the exact same size. Multiplication, it's not about the size. And I'm going to show you. So if I said matrix A times matrix B, that'll give us matrix C, arbitrary. Let's say that matrix A is M by N, and matrix B is, let's say, P by Q. When we multiply these two matrices together, we're going to get a matrix C, which is M by Q. You can see where those numbers come from. They come from M and Q, right? M and Q. Now, there's another thing you have to know. You have to know that N and P have to be equal. This has to happen. So this means that the column in the first matrix has to be the same as the row in the second matrix. The same value. So you can do a 2 by 3 times a 3 by 4. But you could not do a 2 by 3 times a 2 by 3. So I'm gonna start with an example here, and it's just gonna be a square matrix. So example 2. I'm going to say 1, 3, 5, 2 times 1, 1, 2, 0. And I know I can do this because this matrix is a 2 by 2. And this matrix is also a 2 by 2. So you can see that these match, which is good. But then you also know that our end product is going to be a 2 by 2. So when I multiply it is different than adding and subtracting. I don't just say 1 times 1 and that's it. And then 5 times 2 and that's it. That's not how it works. How it works is you actually take the whole row and multiply by the whole column just to get the first entry point. So I'll show you. I'm going to write it down here so I have a, well, I can write it up here. I have plenty of room. To get my first entry point, I say 1 times 1. So 1 times 1 plus 5 times 1. 5 times 1. So again, I take the whole row and multiply it by the whole column to get just the first entry point. That's just the first one. To get my second entry point over here, I still take the whole row because I'm still in the same row, and I multiply by the second column now. So I'm going to say 1 times 2 plus 5 times 0. Again, 1 times 2, and then 5 times 0. My whole row times, I'm working with my column, my second column. Again, that's just my second entry. The next entry, now I'm moving to the second row. But I'm in second row, but first column. So I work with my second row and my first column. So I say 3 times 1 plus 2 times 1. Next, I want my second row and second column, so second row, second column. So I go 3 times 2 and then 2 times 0. Now I can simplify. So to simplify this, I have 1 times 1, which is 1, plus 5 times 1, which is 5. So I have 1 plus 5, which is 6. 2 plus 0 is 2. 3 plus 2 is 5. And lastly, 6 plus 0 is just 6. So this is what I ended up with. And again, we wanted a 2 by 2, like we said, and we got it. Now that's great. It's a square matrix, so we should be able to do it. So let's go to example 3 and see what happens to some other ones that aren't square. Just calculate. The first one. 1, 2, 3, 4, 5, 6 times 0, -5, -7, 3, 2, 6. So the first thing we need to check is when we multiply matrices, if they're middle, so the column matches the row in order to multiply it. So let's write it now. So this here is, remember, it is, when we talk about this, we talk about how many rows by column. So it has 3 rows. So this is a 3 by 2, 2 columns. And this one is also a 3 by 2. Well, you can see that this here does not match here. Therefore, I cannot multiply these two matrices together. I can add them, I can subtract them, but I cannot multiply them. So I move on. I can even say, cannot multiply. Let's move on to the next one. So B. B says matrix 3, 2, 1, -1, 0, and 5. 5, -2, 4, and 3. So I have to check to see if they are the correct size. So this first one is a 3 by 2. And this one is a 2 by 2. These match, so I know that when I am done, I'm going to get a 3 by 2 matrix. I'm going to start you off, and then I'm going to have you pause it and do it on your own. So the first thing I'm going to do is I'm trying to find my first row and my first column. Right? So my entry of my first row and my first column. So I'm going to take my first row times my first column. So it's 3 times 5, and it's going to be -1 times -2. So 3 times 5 plus -1 times -2. To get to my next one, over here, my second entry, I have my first row and my second column. This will be 3 times 4 plus -1 times 3. So 3 times 4 plus -1 times 3. And then you're just going to keep going from there. But again, I'm going to pause this. I want you to finish this problem and then come back. When you come back, it's going to be finished. So go ahead and pause now. How'd you do? Hopefully you nailed it and you understand this. It could be basic, but it could also be pretty confusing at times. All right, so next we're going to look at an actual context problem. And I'm not going to spend time for you to write. You can pause this and write this down. So this says that an investment trust has investments in 3 states. Its deposits in each state are divided among bond funds, real estate funds, and capital funds. On January 1st, the amount in millions of dollars invested in each category by its state is given by the matrix. So you can see there's 3 states, state A, B, and C. There's how much they've made in bonds funds, real estate funds, and capital funds. Sorry, not made, but what they deposit, sorry. Then it says the current state average yields 5% for bonds funds, 10% for real estate funds, and 7% for capital funds. Determine the earnings of the trust from its investments in each state. So we first want to say that we're going to be multiplying this. This is a 3 by 3 matrix. So in order to multiply this, we have to say A 3 by 3 matrix has to be multiplied by a 3 by something in return. Well, we have three things here. We have 5% for bond funds, 10% for real estate, and then 7% for capital funds. So we're going to write our matrix here as a 3 by, and it's going to be 1. Because we're going to say that this yields, this is what it yields, 0.05%. So, sorry, 0.05, which is 5%. We have a 10%. We also have a 7%. And what does this represent? This represents bonds, or bond funds, real estate, and then this is our capital. So when we go and do this, what we're looking at is we have this now set up. I'm going to zoom in, then I'll zoom back out so you can see it. My original one, my matrix that it gives us is 10, 30, 15, 5, 12, 6, 20, 10, and 25. Our yielding is 5%, 10%, and 7%. Now, why is it like this? You think about it. If this whole column represented our bond funds, when I first multiply my matrix, I multiply my row times my column. Well, that means I'm going to take 10 and multiply it by 5%. And 10 was a bond fund, and 5% is what the bond funds yield. When I take my second entry and I say 5 times this, right, because my whole row times my whole column, so it'll be 10 times 5%. Now I'm going to say 5 times 10%. Well, those circle values, don't those both represent my real estate? And then my last one, this 20, and then the 7%, both those triangles, don't they represent our capital funds? So I'm multiplying bonds times bonds, real estate by real estate, and capital by capital. It's exactly what I want to do. So now that I have this set up, I multiply all this through, and I'm not going to show you all the work to it because you can put it into a calculator and write it all out. And you could try this and pause this right now if you want to try this on your own. But what you will get is you will get 2.40, 3.40, and 3.10. Remember, these are all in millions of dollars. So 3.4 million, 2.4 million, and 3.1 million. Now, one final thing for this section, and that is this. This is not even a big one. This is actually a really easy one. It's called a scalar multiplication. So scalar multiplication. It says if A is a matrix that's 1, 2, 3, 4, then I can say what is 2A. All you do is you just multiply every entry in that matrix by 2. So the 1 becomes 2 times 1, which is 2. The 3 is 3 times 2, which is 6. The 2 is 2 times 2, which is 4. And the 4, which is 2 times 4, which is 8. So this is now what 2 times that matrix. That's called just a scalar multiplication, meaning that you're going to multiply every term in that matrix by a value.